Hello, Assistant Professor Dr. Fisan Galprapal, who are Prime Wongsaard and Minsang Kim. Today we'll introduce our Arduino-based home alarm system, which uses a light sensor to detect a door opening, starts a countdown, and then lets you disarm through keypad before an alarm sounds. Here's an overview of our mini project's concept. First, a photoresistor monitors ambient light at the door. When light rises above our threshold, we assume the door opened and then start a 10-second timer. During this countdown, entering the correct code plus hash on the keypad disarms the system. If no valid code is entered, a buzzer and an LED indicator activates to alert occupants inside the home. Next, let us take a look at our Arduino IDE code. So before setup and loop, we have some pre-setup decorations. At the top, we include keypad.h so we can read the 4x4 matrix. We then set two tuning constants, light threshold to 350 and countdown duration to 10,000 milliseconds, which is 10 seconds. Next come our state variables. We have input code, which accumulates press keys. We have disarm code, which resets to 1, 2, 3, 4. We have alarms triggered, which flags countdown, and trigger time, which stores countdown start. Finally, we have set up the keypad, but I won't go into much details. We basically just use what we've learned from this course in this part. Now, let's take a look at the setup initialization. In setup, we've configured pin 10 for the buzzer, which we set to high, so it's off at rest, and pin 11 for the LED, which we set to low, so it's just off. We then call 0 begins 9600 to print debugging info for our testing. Next, let us take a look inside the loop. So for each loop, we call analog read A0 to get the LDR's value. When it first exceeds our threshold, which is 350, and alarm trigger is still false, we record trigger time equal millis. Millis it's just a built-in function which returns how many milliseconds have elapsed since the sketch began. Storing that timestamp let us measure elapsed time without stopping the loop. We then flip alarm triggered equal to true to begin our 10 seconds countdown. While alarm trigger is true, we continuously poll keypad.getKey. Each digit appends to input code. When the hash arrives, we compare the input code to 1, 2, 3, 4, which in this case is just our disarm code. A mash sets alarm trigger to false, which stops the timer and resets buzzer and the LED to off. This all happens while the sketch is still free to read sensors or update displays, because we did not call any delay here. On every iteration, we also check if millis minus trigger time is more than countdown duration, which is 10,000 milliseconds. Subtracting the stored trigger time from the current millis gives us the precise elapsed time since the door opened. When that exceeds our 10,000 milliseconds or 10 seconds window, we activate the alarm. We drive pin 10 low for the buzzer to sound and pin 11 high for the LED to light. But if alarm triggered is false, either before any triggered or right after a correct code, the final else block keeps the buzzer and the LED off, readying our home alarm system for the next door opening.
This is the explanation portion of our mini project. Let us look at our main components. We have an LDR connected to a transistor that is connected to our microcontroller, connected into the A0 analog port. We have an LED, a beeper, and a keypad, all connected from ports 2 to 11. This is the live demonstration portion of our mini project. I have the LDR covered and the beeper disabled in order to prevent noise pollution. However, this LED will act as the indicator as to when our alarm is triggered and when our beeper will be turned on. Once we trigger the alarm and we cover it back up, we can notice that a door has been opened and a countdown has been indicated. This means that once 10 seconds has passed, the LED will turn on. Once the LED is turned on, this would normally indicate that the beeper will be alarming as well. In order to disable our alarm system, we move to our keypad. Our current disable code is 1234 #. Let us demonstrate. Once the correct code has been inputted, the LED will now turn off, signaling that the beeper has also turned off. The same can now be reproduced again once the alarm has been triggered. 10 seconds will pass, and after that time, the light will indicate back on.
And that concludes the video presentation of our mini project. Thank you very much for your attention and interest.